Hello, in this video we will briefly talk about higher order derivatives. So if we wanted to get the nth derivative, the notation would be as follows. So d to the n times y over dx to the n. So this is, as you might recall, when you were getting the second derivative, you would have replaced this n by 2. But for the nth derivative, you just leave the n. And so for the fourth, the fifth, the sixth derivative, whatever, you just change that n to the corresponding number. This can also be written as f parentheses and then n f to the n times x. So for example, the fifth derivative, you would just put f to the parentheses 5 closing parentheses and then of x. As you might recall, for the second derivative, we will put 2 apostrophes, but of course, like if you wanted to do the third, the fourth, putting too many parentheses just gets confusing. So only for 2, you have the 2 apostrophes. The third derivative, you will put the 3 apostrophes, but from then on, starting from 4 and on, you will just put the number in parentheses, like so. And let's work on an example. So let's say you had f of x is equal to 4x cubed plus 5x squared plus 6x minus 1, and you wanted to get the following derivative. So you wanted to get the first derivative, the second derivative, the third derivative, and the fourth derivative, and the nth derivative, knowing that n is greater than 4. Okay, well, so let's just work our way down by finding the derivative, the first derivative, then the derivative of the first, which is actually the second derivative, and so on and so forth. So our first derivative, using the sum rule and the multiple coefficient rule and our power rule, we can get that f prime of x is just 12x squared plus 10x plus 6. The derivative of that is just 24x plus 10. The derivative of that is just 24, and the derivative of that is 0. And so we know that getting the derivative of a constant will always give you 0. And so getting the derivative of 0, it doesn't matter how many times, you will always get 0. And so we can generalize that f of n, f to the n of x, as long as n is greater than 4, it's just 0. As a note, as you might recall, in the quotient rule, your denominator looks like so. And so when the exponent right here doesn't have parentheses, then it means that you actually raise g of x to that given power, in this case 2, so g of x squared. However, if it had parentheses, then it meant that you well, in this case you would have seen the apostrophes, but let's say that it was a 4. Well, if you were to see parentheses around it, then it means that you get the derivative of it 4 times. But in this case, without the parentheses, then you actually raise the function to that power. So this is just to avoid any confusion. Just check if there are parentheses. If there are, then you get the derivative. If there aren't, then you actually raise the function to that given power.